G'day guys, Mr. Bennett here again. Today we're going to be looking at some more questions to do with the unit circle, and so let's just get straight into it. So if I had to do, say, question B here, question B, we're looking at using the unit circle, and we have to find the sine and the cosine for that particular angle using the unit circle. So if I'm using the unit circle, I actually don't draw, I just sort of draw my axes. Now, if we're thinking about pi's on 4, so that's pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4 around here, which is pi. So 5 pi on 4 would be a line that goes over here. So that's 5 pi on 4. That means that this angle in here, in there, is in fact pi on 4. Now on your unit circle that I gave you, for anything with pi on 4, you need to do what? You need to know that that side there is 1, that's 1, and that's root 2. Okay, for that angle there. And so we know that's going in the negative direction, that's negative there. So if we've got that, we can say that cosine of 5 pi on 4 is going to be equal to the adjacent side, which is negative 1 on root 2. And then cosine, sine of 5 pi on 4 is also equal to the opposite side, which is negative 1 over root 2. Okay, so you got the idea in terms of looking at that. If I did say something like C, right, C, okay, we'll go through there. So that's 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4 over here. Okay, again, that angle there is pi on 4. This whole angle around there is in fact 7 pi on 4. We always make our triangle go to the x-axis. Alright, so again we're labelling that's 1, that's negative 1, and that's root 2 using the triangle that's on your sheet. And so remember, key ones are pi on 4, pi on 3, pi on 6, and so therefore we can work these out exactly. So therefore we can go cosine of 7 pi on 4 is equal to, in fact, adjacent side, so that's 1 over root 2. We know cosine is in fact positive in that quadrant, and then we know sine of 7 pi on 4 is in fact equal to the opposite side, negative 1 over the hypotenuse there. So that's those sort of things done. Obviously if you've got negative, that one there, that's going around this way, isn't it? Going around 3, so that would bring you out to this point here. So that would be in fact negative 3 pi on 4, wouldn't it? Actually, sorry, I got that wrong. Forget that. Just obviously it's late at night. If I just change that again, sorry, negative 3 pi on 4 is in fact going to be pi on 4, 2 pi on 4, negative 3. So negative 3 pi on 4 is in fact going around there to that point there. Alright, again, you drop your right angle to the actual x-axis. If we're looking at some ones where you're actually using other angles, so if I was doing, say, B, we'll do B again. Alright, so over here we've got our quadrant, so 2 pi on 3, so we've got pi on 3 and 2 pi on 3. So 2 pi on 3 is going to be a nice triangle there, and obviously 3 pi on 3 is that pi, isn't it? That's 2 pi on 3, which means that this angle in here is pi on 3. Now looking at your triangle, that's like pi on 3 is 60 degrees, means that this side over here has to be root 3, that side there has to be negative 1, remember it's coming from the origin in the negative direction, and that there is 2. So therefore we can say that sine of 2 pi on 3 is in fact equal to the opposite side, which is root 3 over the hypotenuse 2, cosine 2 pi on 3 is in fact the adjacent side, negative 1 on 2. Now remembering the South Australian Tennis Club, So we know that in this quadrant over here, that sine's the only one that's positive. So that makes sense, doesn't it? Alright, here we're going to do question E, which is 11 pi and 6. So we know that going a full circle is 12 pi and 6. So this must mean that if I'm going all the way around there, that is in fact 11 pi on 6. And that means that this angle in here is pi on 6. And so therefore we drop our perpendicular here. So pi on 6 means that this side over here must be -1. This side over here must be √3, and that there is 2. Because that is just one of our special triangles. Now, we know that the only thing that's positive in this region here is in fact cosine. So if we did the sine of 11 pi on 6, that's going to be equal to, the opposite side, -1 on 2. We know that cosine of 11 pi on 6, that's going to be the adjacent side, so that's going to be √3 on 2. Right, so it's pretty easy to actually work out these things here. Now this question says here, without using your calculator, evaluate the following things over here. So, got some options of what we could do there. Let's do question C as an example. Alright, so we've got this thing here, 4 sine 60 degrees, cosine 30 degrees. Whether we're using pi's on 4 or 30 degrees, we know it means the same thing. So I'm going to do 2 unit circles here. One at 60 degrees and one at 30 degrees. Okay, so I've got my 30 degree one. So that's going to be, for my special one, that's going to be √3, 1, 2. This one's going to be 1, √3 and 2. So if I'm doing sine of 60 is going to be equal to the opposite, √3 on 2. This is cosine of 30. Cosine of 30 is equal to the adjacent side over the hypotenuse, that's √3 on 2. So when we go in here, we can say that's 4 lots of √3 on 2 times by √3 on 2. So timesing that out, you're going to get 4. √3 times √3 is going to be 3. 2 times 2 is 4. That's going to cancel out with that, and that's going to leave me an answer of 3. So that actually is equivalent to 3 by doing that process. Alright, let's just do one more very quickly. Let's do, say, H. Alright, H, we've got 1 take 2 sine squared 7 pi on 6. I'm going to use my unit circle again. I'm going to think about where 7 pi and 6 now. 6 pi and 6 is pi, so 7 pi and 6 must be down around here. So that means that that side there is pi and 6, in there, that angle. Alright, pi and 6 is like 30 degrees, so this side is -1. That's -√3, and that there is 2 for our special triangles. Now, I need to work out sine, so we know that sine of 7 pi and 6 is equal to the opposite side, -1 over the hypotenuse 2. So that's going to be equal to 1 take 2 lots of -1/2 squared. So therefore that's going to be 1 take 2 times by, now -1/2 squared is going to give me a quarter, isn't it? -1/2 times -1/2 is a quarter. So therefore that's going to be 1. Now terms that there, it's going to be 2 on 4. So that's going to be a half. So 1 take a half is going to be simply a half. That's what that works out to be. Alright, so the simple thing here you've got to do with these questions is to make sure you work out each of the terms in the question. So I would need to work out the cosine of 60, then I'd square it. Need to work out the sine of that, work out the cosine of that. Okay, so whether you're using angles or whether you're using degrees, radians, it doesn't really matter. For those, I have to work out each of these terms. Sometimes it means I have to use 2 unit circle diagrams in order to work those 2 things out. and then it's just a matter of substituting it in there, squaring it, timesing it by 2, timesing it by 4, whatever you need to do to actually work out your answer. Alright, it's really important that you get the idea that what we're doing here is really no different from what we did in the previous bit. Alright, it's the same sort of thing, same process over and over and over again. So good luck with it. Make sure you catch up with me if you need some help, and I'll try and do whatever I can to support you with that.